Okay, in this lesson, I'm going to show you how to draw a diagram, or in this case, two diagrams, which will help explain the formation of these two coastal features, the cliff and a wave-cut platform. In the image you can see in front of you right now, you have those two features. So in the foreground, you can see the wave-cut platform, which refers to the base of the old cliff. So this is where the cliff used to be. And you have the main feature itself, the cliff, which is obviously moving backwards over time. It's retreating as it collapses into the sea and is removed, which is why the wave-cut platform develops. You're probably familiar with these features because you may very well, in your younger days or even more recently, have spent some time looking for sea creatures and crabs in the different pools that are created by a low tide when the wave-cut platform is revealed. Now, the big question that a lot of people have is, how can this cliff ever be attacked by the sea when the sea is over here? Well, that is because of the tidal nature of the sea. So here in our second photograph, we can see St. Andrews during a high tide. And during a high tide, the wave-cut platform disappears. It is now underwater. It would be possible to wade out into this because it's only a meter or so deep, but you can see the sea is now right up against the cliff. You can see in the background here, which I'm just indicating, an area where the cliff has actually been undercut. What's called a wave-cut notch develops because the sea attacks the base of the cliff, which means the top of the cliff ends up being overhanging with nothing to support it, a bit like a balcony, until eventually it just collapses into the sea. So effectively, these houses along the top of the cliff only have a certain period of time left before they themselves will collapse into the sea. So let's have a little look at what we're going to be doing. You are required to draw two diagrams that show the formation of a cliff and a wave-cut platform. First thing I'd like to do is, using a piece of paper, write that as your title. Okay? And once you've written that as your title, I'm going to be showing you a diagram which I'd like you to draw, and I'd like you to add the different annotations, but what you will notice is that each of those annotations is incomplete. And what I'm going to do is tell you the key information that you need to complete each annotation. So here is diagram number 1. This should take up about half of your page. And we can see a cross-section of our cliff. So we have to imagine that St. Andrews would be up here. And in my second picture I showed you a second ago, where we had the tide in, that would be what the tide would look like. It's coming into contact with the base of the cliff. So what I would do is pause your diagram, if you haven't done so already, draw everything you can see, including the annotations, but leave space to extend these points. Okay, at this stage I assume you have drawn all of this diagram and we're just looking to complete each of the sentences. So let's start at the top of the cliff. The top of the cliff is not getting attacked by the sea, it's getting attacked by weathering, like freeze-thaw action. Now, we've seen this in our glaciated landscape. So freeze-thaw action, which is where water gets into cracks and cools at night, freezing and expanding, which weakens those cracks. Okay. What you then want to put is, this weakens the top of the cliff, meaning that eventually the top of the cliff may collapse into the sea. Okay, so there's your first extension. Those 2 points, you might need to rewind just to pick up the points to extend this part of the sentence and extend this. Okay, another key part of this diagram is we have layers of hard and soft rock. That's quite important. Layers of rock with different strengths, which means the softer rocks get eroded at a faster rate, leading to a notch developing at the bottom of the cliff. So that is the sentence you would add there. This one here, during a high tide, the sea is able to erode the base of the cliff through different processes of erosion. This one here, the notch created from erosion, which leads to the cliff being undercut. Okay, so that undercut's all you need to say there. And you can see the cliff is now hanging over this little notch, and it's going to eventually drop. This one here, hydraulic action also occurs, which is where waves crash into the base of the cliff, forcing air into cracks in the cliff, which expands and causes those cracks to weaken until eventually rocks break away. Quite a lot you want to extend there, so just rewind this if you need to finish off the rest of that sentence. Lots of abrasion, which is where rocks and pebbles carried by waves are thrown against the cliff, eroding it. Okay, so that's the sentence you would add for abrasion. Okay, so you've now got diagram 1 with all of these annotations, and you've extended them using the descriptive statements I've just given you. Let's have a look at the second diagram. Okay, so what I would do now is pause the diagram, draw diagram number 2, and I will extend those sentences in a second. Okay, I now assume you've drawn your second diagram, so let's just have a look at what each of the labels is actually showing. Location of the old cliff, which has now collapsed into the sea. Okay. Base of old cliff, the wave cut platform exposed during a low tide. We don't need to add anything there. My diagram actually shows that we have a low tide present. You can see that in the first diagram we had a high tide. Remains from collapsed cliff at base leads to increased erosion processes on the new cliff face through processes like abrasion. Okay, so now that you've got lots of rubble lying at the bottom of your cliff, the sea is going to pick that up and thrust against the cliff and erode it further. Okay, right, that is this tutorial finished. You should have 2 complete diagrams which you are now required to photograph and upload into the assignment that goes with this particular lesson.